Thank you all. My name is Jacob Grotta. I'm from Moody's Analytics. My group is the Risk and Finance Analytics Division. And what we do is we use data and analytics to help our customers largely with credit questions, whether that's on individual credits, should I make a loan to some company, for example, or portfolio construction sort of questions. Is it better for me to give lending to a certain industry or a certain sector versus another? So I'm going to run through a little bit of what we've done in the past, what I see going forward, and kind of where we are. And I think it's interesting to hear Kathy O'Neill's talk. I think some of the questions that she raised about ethics are ones that the banking industry has been dealing with, particularly in the last 10 years. So hopefully I'll touch on some of that. You'll be able to bring together maybe the two talks a little bit. So just to take a start, you may not realize this, but Montgomery Street, for those of you who are from out of town, and I'm disoriented right now, I think is right over there on the other side of Market Street. Montgomery Street is the cradle of probably two of the most important credit analytics companies that have come to pass, right? The Fair Isaacs Company, owner of the FICO score, was founded in 1954 just on this south end of Montgomery Street. Bill Fair and Earl Isaac had met at Stanford, and they, I guess in the form of original utility computing, used the Standard Oil Company's computers to work on credit questions. And the Standard Oil Company at night let them use it, take their punch cards out, do all sorts of interesting work. Their first project was with the Hilton Company. The Hilton Company had a charge card at that point in time and kind of asked the question of, do we make any money from this thing? Right? Is this actually a functional business proposition? And they went and they found whether or not who they should be giving the charge cards to, how much should they let someone charge against their accounts, and actually also the fact that Hilton wasn't actually cashing the checks they were getting. So that was useful. KMV, which is now a part of Moody's, right, was found on the other end of Montgomery Street, Kellefer, McQuan, and Vazicek, and they focus on corporate credit risk. And this was founded in 1990, and it was, like I mentioned, in 2002, it was doing so well and was kind of viewed as a threat to ratings potentially that Moody's Corporation acquired it. And that's kind of part of the business that I'm associated with. And in our business today, we probably have, I was trying to think through this yesterday, about 200 what we would call quants, what you all might call data scientists, working on these sorts of questions. So it's a pretty substantial group working on a wide variety of things. I would say throughout Moody's Analytics, we probably have about 500 people doing that sort of thing. So 50 years of credit modeling. There's also a long period of credit data. So after the Civil War and leading up to World War I, there was a lot of innovation in credit data markets. I think the most interesting part is probably right after the Civil War, there was a guy named John Kiernan, and he was a Western Union messenger, and he realized that the people on Wall Street were really interested in the messages that he was bringing them. So he hired some people to go row out in their boats out into New York Harbor and meet the ships as they were coming in, and before they could come into the dock, they had to sit out there for a little bit and ask people to throw down the newspapers from London or from wherever the ships came from. And he would have the guys row back, and they would sell the information out of those newspapers to the people on Wall Street. And Charles Dow and Edward Jones were a couple of people who went out in his rowboats. I'm not sure if that's where they met. Presumably it's somewhere sitting there or else having a cigarette on lunch break. And they ended up founding the Dow Jones Company. They started a newsletter, which became the Wall Street Journal. Charles Dow went into index creation and statistical modeling of that sort. John Moody came along, and I like him because a company with his name pays my bills. And in 1900, he started the idea of kind of standardizing analytics on companies. And he started with railroad manuals, and after failing and restarting in 1909, he came up with the idea of coming up with the credit rating that we know today. And for good and bad, it's a standardized way of looking at risk that is a language that we can all at least understand whether or not we agree with it, right? And in his books, which we look at as maybe the original website of ours, this is from 1918, you can see all the statistics he had, his summarization of how he formed and how he did pro forma analysis, some pretty nice data visualization, I would say nicer than we have on our website today. And overall, these things were very popular. He started doing on other companies, and that's kind of where the rating business has come from. So with a long period of time, as Southard said, of modeling and looking at information, kind of want to take now a step and look a little bit at maybe the financial markets. So I'm going to talk a little bit about banks, but you can also extrapolate this to financial markets. So a couple things. One, on the left side, banks are pretty highly leveraged is what this means. So leverage is how much capital versus, or how many assets do you have over your capital effectively. So if I am highly leveraged, if I lose a little bit of money, it impacts my capital, the amount, my likelihood of being able to be solvent quite a bit. Financial institutions run on a lot of leverage. They're also, if you look at the right side, not extremely profitable. And this is taken care of in a lot of different ways in different parts of the world. But, you know, three things kind of jump out at me when I think about this. One is these banks are extremely model driven. So I was talking to someone recently, they mentioned their model inventory is over 1,000 models, over 150 credit models alone in this institution, which to me is probably far too many, but this is where the situation they're at. The models themselves are modeling something that's kind of hard to figure out, right? The future behavior of people or companies or systems. And so there's no scientific truth that they're trying to get down to, which means the models are degrading over time. As soon as a model is built, it's at its peak performance, and over time, as the world and the environment around us changes, those models are getting worse. Second, they're dealing in pretty big volumes sometimes. So sometimes some of these models are valuing things that are $1 billion or more. So statistical significance can be pretty important with those. And I think the third thing, which is really important when you think about the business model of these firms, is their risk, they're adverse. So I was thinking about this yesterday. I got an email offering me to apply for a job yesterday, and it said, you know, congratulations, our algorithm has decided that you'd be a great candidate for this. And I ignored it other than for this purpose, but I'm sure one of the other 99 people is going to do a very good job taking this role. And the company that wrote that algorithm will be very happy, and they hired someone who's going to do this. But if a bank loans, there's 300 people in this room, loans all of us mortgages, and 3 of us don't pay them back, the institution doesn't make any money, right? So loss rates of that sort are real, and they have to be very specific about thinking about the adverse selection aspect of this, right? And as we've learned, mistakes matter a lot, right? So this was a common headline after the financial crisis. I was thinking about this was related to the Gaussian copula, if you've read about it. But I was thinking about it in relationship to a company I met in 2005. I was in the structured finance market that was issuing this thing called a CPDO. You can Google it. It was definitely a bad idea for someone to be doing. They were building synthetic leverage on mortgages, okay? And we went there, and they had this really nice office on Park Avenue on the 56th floor, and we go up there, and these guys are all wearing their really nice Piaget watches and stuff, and they started describing their business model, and one of my colleagues said, you know, I invest in real estate myself. I don't understand how this works, you know. What's going to happen when house prices go down? And they pulled out their pitch book that had been put together by an investment bank, and they said, look, here you go. We're going to be fine, right? This shows that we're going to be fine. And needless to say, a few years later, everything had gone totally sour for these guys. They had failed in a really big way. I ran into one of the people, and we were talking, and I asked about, after maybe a couple drinks, where we were getting to with this. And he mentioned that, yeah, it was the model had told them that they would be fine if house prices went down substantially. But when they looked at it afterwards, after the fact, they hadn't used any data when house prices had gone down to build the model. In the last 20 years, only over 3/4 had house prices gone down in the US. So there was no reason to believe that the model would predict something that it wasn't built on, right? And this is an important lesson for a lot of us, right? And when we think about it, the cost of the financial crisis, some people would say $700 billion. This was what TARP was, which was the Troubled Asset Relief Program. A lot of that got paid back, so some people would try and tell us it wasn't that expensive. The Dallas Fed wrote a paper, kind of interesting, saying it was a $14 trillion problem, right? So between lost wages and all the other costs, $14 trillion is a lot. Now, I think about why this matters, and I mentioned that business models for financial institutions kind of are creaky, because we're the insurers, the people in this room are the insurance company for these firms, right? This is the Federal Reserve balance sheet. So in the last, over the course of the financial crisis, we took on about $4 trillion on the Federal Reserve balance sheet. That's $150,000 for each of us. It's still there. It hasn't come off and gone back into the system. People are predicting it's going to, but so far we're still sitting there. So as the insurers of this system, we have to think about how do we actually write our insurance. I'm a homeowner. I didn't have a lot of say in the terms and conditions of the insurance policy I got, right? Banks have a little bit of sway in that, but in reality, the system kind of starts to think about this. So what's been happening, right? What have we learned, right? We've made some big mistakes in this world, and what have we begun to learn about some of this? And you could think about it as we shouldn't have models. As I mentioned, models are just going to be a big part of banks. As Kathy mentioned, they're just a big part of our lives, right? And the ways that most institutions and really most of the alphabet soup of regulatory bodies have thought about this is to try and instill what I would kind of consider a culture of risk management as opposed to a culture of risk, right? And so this starts with what we call risk appetite. We could spend hours talking about this, but really the idea is to make it clear that there's a language of risk, that there's a currency of risk throughout the organization, and that we think about this in the decisions we're making. So at the top, the board of directors will say, how much risk of different sorts are we willing to take to meet our mission or our values or our objectives? And this isn't only for financial firms, other firms do this as well, but it has become I would say common practice, not even a best practice, and it leads to being able to take conscientious risk-taking. And when you think about how this applies to models, right, the models that we build, it applies to the fact that throughout the organization there's an expectation that someone understands what the model does, what it doesn't do, how is it going to be used, right, and what are the risks inherent in using it, and how can I make adjustments to cover for those risks. So it's not to allow us to think about these blind modeling choices that we have. And there's financial risks, right? So we'll think about a financial risk as how much credit card debt should I issue? Should I issue more commercial real estate debt? How much risk can I take a year's worth of earnings risk in a quarter on my credit risk or on my interest rate risk? There's also non-financial risks, so cyber risk, right? How do I manage for cyber risk? Behavioral risk. If you think about Wells Fargo, if you drive around town or if you listen to the radio or watch TV, you see ads about how they're reestablishing the bank after mis-selling products to people. That costs them, just that loss of faith of their customer set costs them probably more than they've lost in the financial crisis, right? And the common framework for these is to set up a three-line of defense mechanism. And the three-line of defense mechanism, this picture is from Europe. The Fed has a similar one. The Chinese regulators have a similar one. Wherever you go, you'll see, for non-financial risk, a similar setup. First line of defense, if I think about it from a modeling perspective, is the modeler themselves, right? So if you're the modeler, you are encouraged to be honest with yourself and with your peers about what you do and don't know. What can you actually predict? What can't you predict? And what questions are you honestly asking and being asked to solve? It's not an easy thing for people to actually do, right? It's actually a hard thing. Second line of defense is something that I'll talk about in a second. We talk about it as verification and validation. And it's a whole independent body that these institutions are expected to have. Then the third line of defense is internal audit or a governance process. So if I have a framework that people know I'm following that helps me cascade information upstairs and bring it downstairs, and if you think about a bank, I was recently at one, and the CRO said, it's great that you think you can make a model a little bit more accurate if we do this review kind of project that you're thinking about. But is Michelle, my lender in East Lansing, or Mike, my lender in Piscataway, going to understand what drives that model, right? Because if not, I'm not going to use it. They have to understand what information you use? Did you use information about loans in New Jersey, right? Maybe there's a different market. And so that information flow and having a governance process that allows us to flow information up and down is extremely important and one that we're taking into account in this industry, right? So if I think about what validation is, right? This is a Dr. Seuss picture, if you remember. It's from a book where he talks about all the bad jobs our kids are going to have in the future. I don't know if you've read this book, if you have kids. You know, there's the guy who has to mow the lawn that grows faster than he can mow it, right? And this is the bee watcher. So in this case, the bee watcher, the bee wasn't producing really well, right? So the town hired a bee watcher. The bee watcher wasn't making the bee go any faster. The bee watcher got hired. And pretty soon they got this line of monks in tomato suits watching the bee. And as you might imagine, it didn't get any better, right? So you might think that this is QA on QA on QA, and model validation is not that. Model validation is not quality assurance, right? It's not verification. Verification, what I think of verification as is, did I implement the model to do what correctly, right? Did I do the right plus sign instead of a minus sign? Did I make any mistakes in actually coding it up? And that's a typical QA function, right? And model validation is not set up to be, it's not for the sort of person who wants to find mistakes. I can be a pessimist. I like to find people's mistakes. It's fun. I wouldn't be good at this, right? Model validation is really an independent, effective challenge process. So the idea behind that is to help the person developing the model identify where have I and where have I not answered the question, right? Because ultimately that's the only way that we're going to be honest with ourselves and with our colleagues who are actually going to be putting these things into place. So whether it's a lending decision or it's an allocation decision, or you could think of this in other areas like Kathy O'Neill was talking about, if it's whether or not I should be thinking about a parole decision, you have to think about what information went into this and why did I make a decision? One common question we'll get, for example, is GDP and unemployment. You use GDP in this model. You didn't use unemployment. Those both seem to be drivers of real estate prices. And the answer usually would be, well, they are. They're also pretty highly correlated in space and time, right? So if I can use my mental capacity, with limited mental capacity I have, to bring another variable in that might describe something else, that might be of benefit, right? So answering that question is valuable, right? It doesn't mean that it's the right answer, right? Because there's obviously no right answer. But it means that it's been thought through and it's been explained and been shared with people, right? And shining a light on our assumptions is probably the best way to think about this, because the only way we can know whether or not our assumptions are correct is by going into the future. That's not going to happen. At least, we'll get there eventually, but we'll only find out after something bad has happened. So knowing about our assumptions allows us to try and handle the inherent error that is within one of these models. There's a model risk management statement from the Federal Reserve and from the OCC and the FDIC. The top section here is just a quote from that. The validation framework is looking at conceptual soundness, monitoring, outcome analysis, among other things. And down here, this is a lot of what a validation team does. And these are done independently, again, so it's not the modeler. Sometimes it's a vendor, sometimes it's an internal staff. A lot of this is look at the documentation. What has the modeler done? What is the model going to be used for? What data did we have? What data did we not have? Conceptual soundness is an important one, and I think it's an important one going forward, because conceptual soundness says, do I know why the model is designed the way it's designed, right? So this is presenting a particular challenge in the finance industry around machine learning sometimes. And we use machine learning in our firm. A lot of times we use it to help identify relationships, but not to build a theoretical justification for those relationships, right? And we have to have a theoretical justification for the models that we're putting together, right? Back testing and monitoring. So monitoring the models, as I mentioned, these degrade over time, and we have to look at them. And in our group, we have probably 50 models that we monitor of our own that we sell on a regular basis. And a lot of companies do this on hundreds and thousands. And some critical models have to get revalidated every year. So as part of the validation, you identify criticality. And this could be criticality by, I don't think the model is particularly great and it might tip over at some point. Or it might be, it's particularly important to us, right? So if it represents a large part of our business, right? And the revalidation exercise could be done annually. You look at the data, the new data that's come in. You have to look at external factors. What in the world has changed that I didn't think about, right? And that leads to an extremely long process, right? So this is real, right? This is what takes place in a financial institution. It takes a year frequently to get a model into place, right? And by that point in time, you might be going back in and rebuilding it. And it's expensive, right? We spend a ton of money on consultants. A ton of people are doing this sort of thing. And it's costly because you're losing a lot of time, right? So best practice has begun to think a little bit differently, and this is some of the things that we're doing when we work with, use Domino for some of this, which is to allow validation to start happening as we do the modeling. If the validation team can look at the decisions in real time as they're being made, they can ask the questions. They don't have to decide on anything. They're not there to make the decision, but they're there to ask the honest question of, why did you make this decision? There's the documentation part, right? The last speaker talked about being able to do automation and documentation. In some of our monitoring documentation, for example, we just get new data and we can produce monitoring reports quite quickly now. So technology is going to help this, but the process still remains a process and what we have to think about. What do I see? So this is just a little bit about where I see things in the world. So I mentioned this at the outset. Moody's Analytics has been in the modeling business for a long time, let's just say 20 years approximately. And there's a lot more modelers out there, and a lot more data scientists out there than there were 20 years ago. The models that we built 20 years ago are taught in school today, right? So this is not some secret sauce in how to build these things, right? Or at least the philosophical underpinnings of it, right? My children are 11 and 13. By the time they're my age, I'm not sure that data science is going to be like the highest paying job in the area, right? I probably wouldn't encourage them to think about that. Data. We became a data company. We collect a lot of information, a lot of very hard to get information. It allows us to do a good job, I think, with what we do. But the volume of information is growing exponentially, right? And we can't keep up with it. We can buy companies that have data. That's the only way we can keep up with it. So what does that mean? Like, where's the value that we're providing? And I think a lot of what we think about as the value we have is the know-how or the process. And if I go back to what I was talking about, the process of building analytics is as important as the output of that analytics in some cases, right? Because we're putting the analytics in people's hands, and we have to trust those people to be able to interpret and use these things appropriately. And this is, the direction that we've really headed in, not just ourselves as a company, but really the industry as a whole is trying to operate in this way. So the domain knowledge that we have in building these analytics and making a standardized way, if you remember I mentioned John Moody likes standards, we try and think about it as a standardized way of, say, looking at corporate credit risk that we can apply to the data footprint of a firm that sits in the Pacific Northwest, a global bank, I don't know, Wells Fargo, or a bank sitting in the Southeast, for example. And they can look at things simply, and they can use that process with it. So a lot goes into that, right? And then I guess finally, modeling is an art, right? So this is what the modelers I work with like to tell me, right? The software developers like to tell me the same thing. You know a good one when you see it, kind of conversation. I agree, but the world we're heading into is one where this is what I think of as the art. And when we talk about modeling, we talk about an auditable, repeatable, and transparent process, right? So transparent. What does transparent mean to me? Transparent means exactly what I was talking about, where upstream, downstream, people understand the drivers of what the decisions that are made, right? If it's a mortgage, it's the value of the property, it's the buyer of the property, it's what's happening in the local environment, right? Do people understand the drivers of this, right? Is it repeatable, right? The easiest way to think about this is key person risk is a common one. Can someone else actually repeat the process that was done in creating this? If not, how are we ever going to manage to improve upon it? How are we going to monitor it? How are we going to make sure that it's understood? And then auditable means that we actually have, again, a program to think about how we manage this. How do we take new information as it comes in? How do we get it through the monitoring process? How do I look at this and actually think about, okay, is it time for me to re-estimate this model? That's a common decision that we have to make, that our customers have to make, which is, a very important one. It's an expensive decision, and how much extra am I going to get? How much lift am I going to get out of building a new model? And those decisions have to be clear to everyone involved. So, I hate to say it, right? Depending on the industry you're in, you see varying levels of this today, but in my view, this is the future of the process in some sense. And I think back to, a lot of people think of software development, and software development, people didn't always want to use source control and have good processes around that. Modeling is different. It's different than software development, but again, this process allows us to be very clear about what we've done and why we've done it is the future that we're all going to be dealing with, whether it's building very important things like cancer drugs, or it's helping me figure out how to get home faster tonight. This is going to be coming into play. So hopefully there's a few things to think about, how the banking market has evolved, and how it might impact you all. Hopefully, I do have a few minutes if anyone wants to have a question. So.
Thank you, very nice presentation. I was surprised to see that you do model design before you do the data gathering and preparation. Normally I see that the other way around. Could you comment on it?
Yeah. So I think you're right. You might gather the data and see what the data allows you to do. I think the preparation of the data for the model a lot of times happens once you've figured out how you're going to build it, right? You may not know the exact variables, but a lot of times I know what sort of model I'm likely to build, right? Hopefully it's not a great answer, but it's also a very stylized chart, as you might imagine. Yeah.
Yes, great presentation. Thank you very much. You gave us a lot to think about, and I think you started to mention things around like accuracy versus interpretability, and I think that's a big common question in this practice here. I guess in your industry, there's more semblance of regulation than in other ones, but I'm wondering how you think about that. Do you usually try to build models that are simpler so that they can be interpreted at the risk of sacrificing for accuracy, or are you looking into new kinds of techniques that make very accurate models somehow interpretable as well? How do you strike that balance?
That's a good question. It's a very hard balance, right? So let's be clear, right? People hire us to build good models, right? And building a model that is well understood and transparent. So when we go to a customer, they have a validation team that wants to sit there and understand everything. And for a vendor, it can be kind of hard for us to open the kimono up entirely and show them what we think of as our secret sauce. And there's some rules around that we get to. But ultimately, someone within the institution has to get comfortable with it. And we definitely look at ways that we can improve the predictability of the models. A lot of that is bringing in new types of information, right? And so you might take social media information or other behavioral information about people instead of looking at fundamental analysis, layer in other things. And it's important that, going back to, we think about what that data actually represents and how important that is, right? So, the value of accuracy is real, right? Like I said, if I can prevent a default, 1% defaults, that would be a huge, huge benefit for people. But the other aspect of it is there's so much, idiosyncratic aspects of the decisions that are being made that you're also dealing with, when you build a lending model, the lender, a lot of times, is someone who's, older than I am, who is sitting there thinking, well, I understand these customers. Charlie has his mortgage with us. I know his kids are at school. He's paying the bills. His country club dues are fine, and I'm going to give him a loan anyway, right? So I think we have to balance actually a lot of that knowledge that people have in their heads against what the data tells us. And so you'll see Some firms use a model as 80%, some use it as 60%, and I don't have a perfect answer for that, but it really depends on the user is a big part of it and the culture that they want to have. So, all right, thank you.